Oh, yeah, okay, we're on.
Yeah, great. So first, hello everyone, and welcome. We are having sure fun exploring many things together, but in Gimbalabs about ACAM, Bluetooth, other stuff, politics. Yeah, people love politics in Gimbalabs, apparently, But we decided to go with something that really is going to, in our opinion, the change Cardano landscape, and that's the whole Golang tech stack projects and organizations are building, and we believe that it reached to a point that it's a good time and maybe it's a great time to talk about them. And I'm not talking about just one library or two library. No, I'm talking about whole set of tools that you can build your business logic, dApps, idea, project. If you have even a traditional organization, you want to bring them or on board to blockchain, and you want something not only uh, fast or scalable, performance wise. Yeah, sure, all of them, but we have some languages that they are claiming or also proving that they are doing great in those, like for example Rust, but simple and easy enough for most people to just use them and start their projects instead of spending months or even years of just trying to climb up this learning curve and eventually finding out that maybe the thing that they learn is outdated or obsolete or something. So yeah, Golang not only is just getting more attention and mm, I can say that even adoption in Cardano, but in other blockchains, for example, Algorand, Polkadot, Hyperledger, Hedera, Ethereum, of course, and even Bitcoin OS is really getting again attention and momentum. So I think all these projects that I'm going to mention them, and actually Blink Labs, Chris is here from Blink Labs here. They realized that it's really a good time to have interoperability between Cardano and all these other blockchain as well. So in this session, hopefully we can have that in every week at the same time. We are going to explore Cardano and Golang specific tool set, libraries, topics, agenda. And we are going to focus on just building. I mean, sure, today is going to be probably more talk than building or, I don't know, bug smash or something because, well, this is the first meeting after months of not talking about Golang, because the last time that we had a really good focus Golang and Cardano Golang related stuff was Go PBL, and we have a course about it. Actually, let me share my screen. Do I have the? Yeah, I have the. I hope you can see my screen. So in our Andamio platform, if you go, well, I can actually share this link to you. You can see that we have a Cardano Go course. And this is a series of videos and notes and discussion around Cardano, Golang's, some of the fundamental things inside the Cardano, and how do we use them or how do we interact with them with Golang or Golang programming. And also one of the main focus was on Apollo library, which is going to happen and the focus in this session, upcoming session as well, especially since Fund 13. I mean, Apollo proposal was got funded in Fund 13, but there are a lot, and we realized that this course actually, which we are going to go through it, review it, and see what needs to be done, what needs to be refreshed, renew, whatever. But just giving you just some example of how many tools, how many libraries, which by themselves can have courses, modules we have, and we need to work on them. Like, of course, Blink Labs, just go to a repository, you are going to get amazed. But in some of the libraries that I choose here to just showcasing that these exist and just going through and talking about them, how we can use them and putting them in our tech stack. Like, front is this, the smart contract is like that language or whatever, and this is the off chain. The off chain is all the orchestrated things that are working. And okay, I see these new tools. So how can I use it? So that's the thing that we are going to explore in this session. Like, okay, there is this NView, a TUI for monitoring Cardano, or Go reverse. Well, or Go implementation of Cardano Go reverse family, and all this from Blink Labs, Dingo, are coming from Sunday. Okay, Sundays are Kugo or Acmigo, or all these things, and of course Apollo. So all these libraries, all these piece of uh, tech that we need to know when should we use it, how should we use it, and of course where should we use it. So this session is going to do that, and people who are working on these things can of course bring their question. We can work on it. Same thing with Plutus PBL or any other PBL that we have. If you are a Golang developer, good for you. And if you know Cardano, again, good for you. And here we can just explore and talk about new stuff, which eventually you can become a contributor to these libraries. Well, that's again another endpoint of this whole session. Like, just now, we don't want to sit around and talk with each other. No, we want to get something out of this session, and hopefully we can provide something for whomever, whatever level they are. So yeah, if you are expert in Cardano and Go, and you have good idea, well, there are all these libraries that needs contribution. I mean, of course, they are great already. For example, Apollo. Let me show you that we had some benchmark in them, and benchmark result that I reached. I think I put that in the docs, that it reached like a 1 million transaction, and it reached to the 2,695 transaction per second with zero failure. And this is the library that is going to be, it's already great, and it's going to be greater. There are a lot of things that need to be added. It's going to be really great first-class library. So yeah, we have already some great tools and all other tools. So yeah, this is the topics or agenda of this session and meeting. Okay, I think now it's the time for helping you guys out. Like, do you have any question or anything? Anything you want to share or something?
I'll start.
Sure, go ahead.
Can I write a smart contract in Go?
Well, so far not yet, but we have something again. Blink Labs teams are working called Plutigo, and Plutigo. Did I click it? They put it here somewhere. Other Cardano. Just you see that these are. Oh yeah, here Plutigo. So Plutigo is anti-Bluetooth core in Go. So it's basically the whole Bluetooth core, the actual smart contract on chain. So what you are writing with ACAM, Bluetooth TX, which they call it now Plinth. They've changed the Bluetooth TX name to something else, if I remember correctly.
Yeah,
Plinth.
Plinth.
Yeah. plenty. Yeah, and with other languages, any other languages that are, like the Python one, Rust implementation, Haskell anything. Eventually, it has to comes down to Pluto's core, and Pluto's core is the one that actually a the Cardano node execute. So there is this library that Blink Labs teams are working on top Pluto's core. So I think, that's my guess. But Chris is here. He can give his feedback, comments about this, and in
Yeah,
the future.
we had a meeting yesterday on our Discord about going through the VM and then going through the Rust in Aiken and looking at it and what we're going to be doing. And we've got someone from our team that's going to pair directly with, excuse me, Lucas from the Aiken team to help us write the engine. And then once that's done, we can write obviously pretty easily a Go compiler, so we can write a Go to UPLC compiler. So it's possible. It's not really on our roadmap, but someone else would be able to do it using the same, using Pluto Go as the UPLC. So
yeah. So yeah, definitely. So in order to have that smart contract writing in Golang, sure you need to have this. And once this is complete, which I believe it's really pretty in good shape, but of course once it's complete, someone else, I don't know, a proposal from 14, 15 something can pick this up and say, I want to write in Golang. I want to create this smart contract language, domain specific, or the usual Golang syntaxes. But the smart contract, again, integrating all of that into one. We have, and one again, maybe this can open another topic, that again, why should we use Golang? Well, some of the most important blockchain, like the one that actually, sure, everyone who is Bitcoin maximalist call everything else shitcoin, everyone calling each other shitcoin, but the blockchain that really creating some innovative solution that when we look at the tech stack, we see, okay, there was a bright mind here. Putting everything financial aside, for example, Cosmos, they have Golang already. Like there, you can, if you learn this language, if you all this blockchain kind of similar to each other. Sure, Cardano is UTXO based. The whole estate managing things, transactions different. But once you have this syntaxes similar, once you have all these tech stack, SDK, it won't take you long to just interoperate. Like you just create your dApp, be blockchain diagnostic, just doesn't care about that. Choose whatever best for your dApp or Algorand. Like we have official implementation in Go or Polkadot. So these, of course, Ethereum. Ethereum is famous. Like we have Go, we have SDK. There are these interacting with chain and Solidity, compiling EVM, and we have all sort of Golang stuff with Ethereum. But I just wanted to showcase. And if we want to say, okay, why Cosmos? Well, the whole Binance chain was fork of Cosmos. So everything happened here is going to happen in Binance chain or BNB as well. So whatever you use the Cosmos, you can use it on Binance as well. So if you look to the top 10 of all this blockchain, or top 20 even, Golang is just becoming kind of this universal language. And again, coming back to our Cardano, we have all these tools waiting for us to just just use them, and then it would be up to you that you like, I don't know, for example, Node written in Golang or Node written in Rust. to be honest, when I first look at this transaction number, 2,695 transactions per second, I was really wondering that what sort of node can handle this much of transaction, or what sort of TX submit API can handle that. So you might have really, it's like putting a great engine on a really old car, or this this is going to become a problem for itself. So yeah, that's the plan, and we can start, as I said, looking into what we already did, and talking about actually what prerequisites you need. Like, for example, here, does this look enough? And if these modules are enough, we can start just again picking up where we left things off and continue. And sure, if you guys have any suggestion to look into one of these tools, or just focusing on that for like if you are working on something or sure, again, you are welcome to suggest. But yeah, that would be plan. So since James, I think James, are you the course manager of this thing? I think.
Yeah, I started this one, but we can add people as we go, and we can talk about how to onboard contributors to it if people are
Exactly.
interested.
So do you want to talk about the whole onboarding and the status of this course?
Sure. Well, what you could see here, and you can see right away from taking a first glance, that a lot of these modules have learning targets, but not all of the lessons written. So look at module 102, for example. You can see there's a list of learning targets. There's 6 of them, but there's only one lesson that's written so far, right? And so what we have the opportunity to do is together set priorities for what we want to help people understand, but then we also have the opportunity to think about why we want people to be able to do these things, right? Why do we want people to be able to build transactions in Go? Oh, because when they can build systems that do X or Y or Z. And the same could be said about any one of these, right? Whether we're making queries in module 201, using indexers to react to chain events like you see right there in 103. So this is the opportunity ahead of us, right? We can first decide if these are the things we want to understand how to do, and then once we do, we can flesh out the lessons here by working together right here and making sure that the content is good. And finally, once again, most importantly, we have the opportunity to figure out what all of this is good for. What projects can we put in front of people? How can we onboard people, for example, to contribute to the Apollo libraries? Does anybody have questions like about that, like where we're going from that perspective? Erez, yeah.
Yeah, I have a question, not exactly about that, but if you scroll up a little, I really like the art actually for the intro that you have up there, and I was just wondering who drew that.
I don't
Sebastian
know.
created
Maybe
that.
you should ask
Yeah.
Sebastian.
It's
Yeah.
Sebastian.
I
Yeah, it's
posted
Sebastian. Yeah.
Well, I mean, the background image, right? Like I am sure I posted that on Twitter one day, and then
Oh, nice.
yeah, I was from like one of the sets of Go, uh, you know, Go first sets I was going through, that are all like public domain for use for exactly this sort of stuff. So
And Go is a Google. I mean, we know that Go is going to stick around because it's sort of associated with Google. Is that
Not
correct?
entirely, to be honest. Sure, Go started because there was this need for their cloud, their infrastructure, and they were using C and C++ for running all sort of infrastructure in their data center, cloud infrastructure, And they realized that, I mean, I'm not talking about the learning curve, but if one new programmer comes and that person wants to just opt in on board to this new team, well, each person, I mean, you guys know, especially in Haskell, each developer have their own tastes. They have their own style of writing codes, just, I don't know, using tab instead of a space, or I don't know, break lines, whatever, writing loops in their different forms. So that actually creates issues, that create delays. Like someone just comes and what the hell is this thing? And, it takes time. So they were thinking that how can we have a language which is really compiled and fast and really light, like C, not even C++, like C, and people just learn it easily, and just a new programmer comes and understand the things quickly. So they don't doesn't need to deal with this so-called quote unquote legacy code that who knows what. And if you even leave 1,000 of lines of comment, still you don't know. And if you just change, I don't know, an integer, everything blow up. There's this language that just the syntax talks to you. You don't need to just go through every textbook to learn what the hell is these patterns. And of course, it is safe, statically types. And then there were this another problem. Uh, Back in that, I mean, I'm talking about almost 15 years ago, CPUs became like more CPU in one. I mean, they now they have more cores. And how can we use these cores efficiently, especially in the servers? So yeah, you should have this concurrency, parallelism, codes. So C++ and C were all sort of, they have all sort of libraries. I mean, they were writing, but they have issues as well. Like you had to go through all sort of safety for memory leaks, threat channel managing, garbage collection. So things were really kind of hard, especially with C++, because if you leave one function or something, easily you would have create all sort of vulnerabilities, binary exploitation vulnerabilities, like integer overflow, underflow, and all sort of stuff. So again, they thought that what can the same language that I just talked can do all these concurrency channels, thread management easily, and do all this in really great performance wise without us, or I mean developer, being worried about just garbage collection, memory leaks, and all sort of stuff. So yeah, that was another need. And then, well, some of the great people, the great mind of programming, one of them was actually one of the founder of C, started to write this language. And yeah, then the Golang came to be, and then they use it. I mean, it was closed source for a couple of years, and then open source it. It wasn't really great at the beginning, but slowly it became great. And sure, the community actually enforced. I mean, it is now, I can say, language of community after adding generic to the language. Like Golang was resistant to this thing for years, and then eventually they added generic. So like Golang is really a strictly static type. Like if you put something as like integer, it has to be always integer. But generic kind of open. And we had interface, but anyway, we are going to see by the way all these things. We are going to implement not actually in all these libraries, especially like Ouroboros, which is the I think the biggest one, have all of these. But yeah, the whole idea was, for example, let me show you um, the one that actually I wrote for the concurrency things. Like just using Go as a syntax. Yeah, it's well, we developer doesn't have really good idea of naming things. So yeah, Go language and use Go. Using Go for the whole channeling, thread management, concurrency thing, and just writing a function, and that's it. Like just we can, of course, I mean, here we define this waiting group, and again, that's it. That's it. Just we created this concurrency, and actually here in the this benchmark, you can say like how much parallelism. Like in that benchmark I just showed you. Let me duplicate. It was like hundreds of concurrent execution for building this transaction was running next to each other, and it's really great memory wise. Like they don't really consume that much of memory or RAM either. So that's why if you want to write a concurrent, like for example, especially a transaction handling, which in a DEX especially, I cannot say like 1 million, but a really great number of transactions can happen exactly one time and simultaneously. Well, you need something that can handle all these things. So parallelism, concurrency is something can stand, above all the other languages. Sure, the performance of some of other languages is greater. You cannot select even Haskell in some sense, but the easiness, just understanding, just handling things with ease. I cannot. I mean, if anyone saw any other language which you can have all this, parallelism power within just like 10 lines, yeah, just show me that. But yeah, the ease, the simplicity, just the language, which a small, and again, for example, this function, whomever write the best Golang programmer, senior developer for hundreds of years of experience has to write it like this. The person who just started Golang today, right now, has to write it like this. So yeah, I mean, that's a great thing. For example, about something there is this called hash table for benchmarking a language. In order for you to just test yourself even to see, okay, I reached a really great level of programming knowledge of any program. Normally people suggest, yeah, write a hash table. I won't go to the details of what the hell is the thing is, but hash table writing with Rust, at least it took, I think, 3 years to write a really, really good hash table. But in Golang, probably 4, 3 even, just to reach to a level that really a senior developer can write. So yeah, so writing a good code, writing efficient performance, simple code for new developers would be it would happen much sooner than other languages, even JavaScript, though JavaScript people call it like easiest one to learn. But again, performance wise, good code, linter wise, all these things, you will have that easier. So once you have, for example, your transaction or node or blockchain explorer, or for example, Dingo, writing that or using that in your code, you can kind of be sure that your code is almost 90%, not or 95% even performance wise great. And if you want to squeeze, the last nanosecond or picoseconds of that performance, sure, you can spend your next half year or weekend to just doing that. But just if you care about even millisecond, you can say, okay, I'm good. The code is great. It's working perfectly fine. Sure, once I reach to the Google or at the Amazon level, yeah, I will try to squeeze those nano or picoseconds. But right now, it's great. It's just it's great even on my hardware. Like, I don't need the biggest hardware, memory, CPU, wise, to just run the whole thing. Yeah. And also, I should say, the whole Docker, Kubernetes, all sort of things, virtualization you guys are hearing, again, happening by Go. And one of the main reasons why it's happening with Go, because how light it is. So again, if you want to go with Docker, Dockerization, orchestrating all this thing, again, Go with all this thing can help you. And in fact, the Blink Labs already also provided some of these Dockers for you, and like Docker Cardano CLI, Docker Cardano config. I think there was a Docker DB sync as well somewhere.
There is.
There is a Docker which is really, it would create your life easier. Like, and another point, maybe no one's talk about, because of the Golang code is. Like, I mean, again, the simplicity, performance, everything. If you want to use an AI assistant, you can coming back to Er's point. This AI really can give you great code if you want to use AI, because how simple and how efficient, performance-wise, great this code is. But if you want to go with Rust or Haskell especially, no. I mean, actually, me and Adrian found out that all these benchmark they are making for AI, I think they are using some for Go or JavaScript, something. For Haskell, it just create most of the time gibberish garbage thing. Like, that code doesn't make sense at all. So why is that? Because, well, Haskell is Haskell, right? Haskell is difficult in many levels, even for AI. So even for an AI, if you want to use Copilot, whatever assistant AI you want to use it in your life and your IDE, this is great. This is just tell to your ChatGPT, hey, I have this function with this, and it really can understand it much better than Haskell.
Hey, Mix, Nelson
Chris.
has a good question in
Sure.
the chat as well.
So
Any
Nelson asks,
difference? Any difference? Yeah.
in UTXO RPC supported Cardano Node API and Dingo. I haven't checked out Dingo yet. Well, Chris answered that, and he said that data comes from the local DB. VS asking anyone else, it should match. But we've not done much conformance testing. But I can say one thing about UTXO RPC. I don't know how much you guys know about protocol buff. So again, what should I go search to show you? Protocol buff. Golang. So protocol buff, not bug. So protocol buff actually is going to be really, gRPC, really great. I saw there is this library mlab build for protocol buff in Haskell, which I feel that no one is using that because how complex it is. But again, something like protocol buff, again, is really great in Golang. It's easy to understand and use, and especially like something like gRPC. And maybe, I'm going to give you an example of why it is great. Well, let's say you're in your JavaScript, you have a backend. You have a front end and backend, of course, yeah. And there is this database. So in order to just you to query your backend and get some or retrieve some information, you need to just call an API, and then your backend query that database, retrieve that information, and send it to front end. That's the usual. But with protocol buff and especially gRPC, you can directly from front to retrieve that data, and you don't need to retrieve, for example, there is this table of 10 information, like names, phone, whatever. You don't need to just query the whole table and then filter out the one information you want and just put it. I mean, it's traffic. No, that this technology allow you to just retrieve that exact one, that exact information, and get it. That's all. So your front can even execute something. I mean, sure, you might say, wow, there is a security issue, a SQL injection, this, that. No, no, no. There are many safety concerns there. I mean, I can say it's really mature uh, protocol. But I can say that, yeah, protocol buff with Go, though I should say again, TX Pipe is working on gRPC with Rust, with their implementation. But Go is really ahead of many other languages regards to protocol buff. So UTXRPC in Go node, and then protocol buff, I can say, especially even to Gorobros, I think it would be a win for Dingo, but I don't know. Maybe Chris or anyone else can have more insight. That, yeah, sure. Chris, would you please just explain it, what you are writing?
Sure. Yeah. There's actually a whole UTXO RPC module in Dingo, and the design for it right now is it pulls everything from the ledger state out of Dingo using the ledger state queries that are built in. So most of this code was ported from Cardano Node API, and the actual specification code. So if you click on any of these guys, like click on a query or UTXO RPC, it doesn't really matter, any of them. You'll see that you'll see Go code gen in here, right? Like, so you see the GitHub UTXO RPC Go code gen in the imports. And we use various packages from within that, but that Go code gen is generated automatically from this protocol buffers definition. So the protocol buffers, if you go to the github.com UTXORPC spec, that's the actual protocol buffers specification. And so from that, we generate multiple client and server frameworks, right? That's what the Go code gen is it's both client and server code. There's also a Go SDK for the client to make it even easier, but this is all server side, so it's just directly importing everything. Yeah, and so this Go code gen is, again, it's auto-generated code directly from the spec. I maintain it loosely, just like to keep other things up to date and that sort of stuff. But you can see it's auto-generated otherwise. All the releases are auto-generated. So when we create the release in the spec, it auto-generates out to here. And that way everything is the same. So, the question of what's the difference in it between Dingo and Cardano Node API, the answer should be 0. And that should also be the case for Dolos and Amaru in the Rust world. So if you were to write an application using UTXO-RPC that uses Cardano Node API, you should be able to swap out Dingo for Cardano Node API in your backend and see no difference. You should also be able to swap out Dolos or be able to swap out Amaru in the future. So the idea is we're trying to build, kind of like a more universal protocol, right? Like that's the idea with UTXO-RPC. And then eventually be able to make it multi-chain also. So
Is there how much of a code difference is there in the implementation in Dingo and Cardano Node API? In Cardano Node API, it's getting the data through from a node through HTTP or TCP, right? And the one from the
yeah,
Dingo.
so in Cardano Node API, every query that you make via UTXO RPC is essentially proxied into an Ouroboros query directly to a Cardano node. So it's getting its results and its answers from a Cardano node. Dingo, every query that you make, while the shape of it is the same and all of that sort of stuff, the data source for it is Dingo itself. So it's whatever Dingo has stored in its own database. We've done, no conformance testing, as I had said before. We've done no conformance testing yet on validating, that things are correct between anything, and that's some of the stuff that we're working on in the Omaru project. And so when that stuff happens, the idea is we're going to compare things against the Cardano node, against, Amaru, against Dingo. And the idea will be is we'll use Cardano Node API, at least on our side. The idea is to use Cardano Node API as the reference implementation, essentially, because it's querying the data from the Cardano node directly, right? So the response data should be the same, and because we know that the data shapes are the same and all of that sort of stuff, because it's all generated, right? That's the advantages of using protocol buffers and gRPC for UTXO RPC is all of the interfaces for everything is all automatically generated, right? So that you know that all of them can at least talk to each other correctly. Right. And so then at a certain point, it's just validating that everyone gives the same answers to the same questions. And, like now we have essentially a universal protocol that we can use fairly easily across languages. So that's the goal that we've been going for with it. So yeah, if you look through this, for example, in the implementation, like all of these things, like the query service server, the read UTXOs, like all of that stuff's already predefined. We're just writing to an existing interface that was already auto-generated. So we're just filling in the actual implementation of it. So like the UTXO RPC stuff already says, the query service server has to have a read params. It has to take this as inputs. It has to take that as outputs, right, and all of that sort of stuff. So the main difference is exactly what Mix just highlighted. If you go back to like the proto params or the so no, what you sorry, go back the line you were on. Yeah, right here. Yeah. So if you look at the proto params here, if you look at the Cardano Node API implementation, what's there instead is going to be a query to the Cardano node to get the current protocol parameters, right? Where we get the chain point here, there's going to be a query to the Cardano node to get the current tip, which it's going to equate to, convert to a point. Otherwise, it's the same, right? Like, in fact, I implemented all of this by taking the Cardano Node API code, migrating it over, and then switching all of these, internal queries to be the ledger state queries.
Hand is going to fall off.
Excuse me.
It's amazing.
Sorry.
Uh-oh.
Go ahead. That's Chrissy's on Cardano over coffee over there and had to blurt
Are you
out.
sure? Are you sure,
Love it.
Chris? Or she's fighting with Charles Hoskinson and just telling him
No, she's
that intersect sucks.
No, she's not. She's talking to Jen. Cardano.
That's great. Oh man.
Cardano in stereo. I don't know how y'all do it in the same room. It's amazing.
Yeah.
I usually don't. So
Okay, so sorry, Chris, you were saying.
oh no, that was it. Is I copied over all of these originally from Cardano Node API, and just to give an example of where this also helps with development speed, is I implemented essentially this code in Cardano Node API once, and I didn't understand it the first time, right? Because it was my first implementation. This one took me like less than a week. Doing all of it in Dingo took like less than a week to completely implement the entire API, which was pretty fast because it took, it was essentially an entire milestone on its own in Cardano Node API, just, to figure out how to hook up everything and get all the queries and convert all the things from how the ledger presents it to how UTXO RPC wants it, versus here. It's so much easier. Anyway.
It does look very
Yeah. So, Chris, if you want to suggest that, where should we start? Like, where would be the good start of just, starting with Golang slash Cardano tech stack environment? Which library or which, I don't know, tool or anything you'd suggest that would be the good start for I can say like the people who are really familiar with Golang but not that much familiar with Cardano, or actually they are familiar with Cardano or not that much with Golang. So I mean, we don't really have the really
So,
complex code or really
right.
complex
So
Cardano.
sure, but this is obviously a I would say a perspective based question
Yeah,
because, for example, I very rarely build transactions or do transaction building in Go, which is the reason why Blink Labs does not have a transaction building library and why we always use Apollo and why we
um,
never had one of our own. We never started one of our own. We've chosen to always just use Apollo because it's never been a first class thing for us. We generally are writing stuff at the protocol level. And because of that, Eduardo actually decided to not go deeper. He was originally planning on making all of the mini protocols and all of this sort of
yeah,
stuff at Apollo, and he saw how much work it was going to be and realized that it made no sense to duplicate all of the work we were doing in Goroboros. So they're very split projects, and it's whether you're building infrastructure or whether you're building applications, essentially, right? So if you're building infrastructure, I would say something like
Goroboros, Dingo.
no, no. I mean, that's probably not where I would start. I would probably start with like Adder or the UTXO RPC Go SDK. It's not well documented, but it has full examples of how to run various queries and that
At
sort of
least we
stuff.
have some example. I mean, is this the example
No,
of
not
the
here.
code?
No, no, no. In UTXO RPCs,
The one that just where was it?
UTXO RPCs
Yeah,
org. Yeah, yeah. Here, there's a Go SDK also, right there
go
at the top.
SDK.
Yeah, first guy. Yeah. So there's a Go SDK. If you look at examples, there's a ticket to document it. But if you look at examples, yeah, maybe throw that in the chat. So we have examples for the various modules and how to use them, and you can see how to use the SDK. And anything that's in here should work against Dolos. It should work against Cardano Node API. It should work against Dingo. Right? It should work against whatever. You can see here by default, it's using Demeter, right, on the preview network. So all of the uh, parameters and things like that that are given, you see in here, like that UTXO is going to be on the preview network, right? In read UTXOs there because we're using the preview network in the code. But the point is this should be code that can be used, and we use this code directly for validating Cardano Node API against Dingo, or sorry, against Dolos. So we were testing against Demeter, which runs Dolos, and then testing using the Go SDK itself here, the UTXO RPC new client right below, and connecting and then running these out of the SDK. These are like wrappers. So if you scroll down and look at like what read UTXO actually is, like
Read
scroll down a little bit,
param,
there's
read
read UTXO here. So you can see we've taken these text representations and we'll turn them into the actual like UTXO RPC representation. So if you scroll down, well, that there was actually
message. Yeah,
that one was easy. That one was super easy because it the
yeah.
input is the same. But yeah. Anyway, so if you go up to the top, the actual top level of Go SDK, the top of the app, you can see there's also this Go mod. No, sorry, go back to Go SDK. kind of weird with someone else driving. Yeah, you can see, main is the main client and that sort of stuff. But there's also query, submit, sync, and watch that match up with the query, sync, submit, and watch modules in UTXO RPC. And it has methods for all of the client methods in the SDK now. So you can see, there's a
New query service client, query
But yeah,
service
there's query
read
service client.
params,
But
which
yeah,
we
that's what I
use
mean. So
that.
there's like read params, there's read params with context. So each one of these before, we made you run the entire query yourself and create and construct the query yourself.
Yeah.
And now we do all of it for you. So like here below where you see adding the headers, all of this, if you look at read params with the request, you'll notice read params just wraps read params with request.
Yeah.
Or with context, sorry. Read params with context. So, like we add the headers to it, which means if there's any authorization or anything like that, it gets added automatically. So in the examples, you can see how to add a header. But this will actually add any of the headers that you tell it to add to the requests. So that's how you can pass your auth or, like anything else that you need to do.
And actually, let me show people that, okay, look at this function, how it is. And then let me show you one example in Apollo backend that how we have to go through all sorts of crazy stuff to just get these parameters. So, for example, this is the same kind of latest block, or just we're getting the params from the Maestro, and then kind of query it here. It's the latest epoch params that it has to go and query the Maestro, converting everything here. And again, this is really slow, but just using the where is that UTXO-RPC here? This can just do that for you. And if something changes with Maestro, well, good luck to go through the Discord, talk about and just changing, create pull request. I've done it, so I know. And then there is this things that needs update, which stops you from upgrading your code. For example, this guy, cost model. Why? Because cost model changes with Bluetooth to Bluetooth. Version 2 and 3 are different. So yeah, this can be really a headache. And actually here in Maestro, it's just commented. It's going to be supported. But here, no, we don't. There's just, you can get the whole thing just, done with it.
Yeah, and I'm working on actually on a UTXO RPC backend for
Yep.
Apollo.
Yep.
So Apollo will use this Go SDK here that I'm showing you, to actually get and query all of the information from UTXO RPC.
Yep.
Can you
that's
for read TX? Yeah, absolutely. I mean, I think that's it's a good one, and I can definitely talk with the rest of the team to try and get that one in.
sure. But I saw Nelson hands. Nelson, did you have any question or comment?
Yeah, I was just asking, like, for the specs to support other parts. For example, like specifically for read TX in the query, because yeah, for Andamio we need a couple of we need that because some transactions depends on previous transactions needing to happen, specifically on the redeemers. We're validating through some redeemer stuff in the next transaction. So we need the read TX endpoint. I saw it commented out in the specs, which wasn't support. Like, yeah, they were. I think there was a talk whether we should this is supported or not. So yeah, I was just asking that to get the specs to support that part. which people are we going to consult, and then specifically working on the Dingo and Node API. It's I'm assuming it shouldn't be that of a much complex task to implement the RTX, right? Yeah, I just wanted to ask it.
No. The implementations in Dingo and wiring up any of the UTXO RPC stuff has been, like I said, very, very easy to implement. Like if you go under UTXO RPC here, since we're already talking about it, and you're in Dingo, go look at UTXO RPC and go look at query, and go look at what it actually does. I mean, for any of these, you can see that's the client. Of course, that's not going to be any of the ones I was asking about. Give me a second. Go back to any of the other files in this directory, but UTXO RPC.
Oh, what if
Query,
submit?
yeah,
Because probably there's TX submit here.
yeah, sure. There's definitely
Yep.
submit TX in here. Yeah. So you'll see there's a submit TX, and so we create a response, and because submit TX actually supports a list, right, of transactions, so you can provide any number of them to it in UTXO RPC. So this is how you can chain transactions easily. UTXO RPC supports it like natively, right? So you can just build a chain of transactions and just pass them, right? So you can pass them in big chunks. Anyway, if you scroll down, you can see, you can see the implementation. You're going to scroll pretty far past it if
Wait
you're
for
past it.
TX.
Yeah, you already passed it. Scroll up.
Sorry.
You went too fast. It's too short. All right. So the only thing that we do is we take the transaction that we get, right, and we generate a mempool transaction. So we directly, stick it into our mempool in Dingo.
Oh,
Because there's nowhere to send it, right? Like Dingo is the
Yeah.
node. So when the transaction comes in, we directly put it into our mempool. So this error equals, see where we say add transactions to the mempool, like SUTXO RPC config mempool transaction, add transaction. That's where validation goes, right? Like so in that actual add transaction in mempool, that's where we do any like validation or stuff like that. It's not implemented yet because we don't have all the rules. That's what we're working on. But that's essentially where that kind of thing would go. So just showing how like the implementations work, right? And then all the rest of that is just building the results stuff. But it goes through and adds each one to the mempool directly by adding it directly to Dingo's mempool, which means that any other node that communicates with it will be getting those transactions over Ouroboros. So it would propagate that onto the network.
We are assuming the transaction is a good transaction. Like, what if a bad transaction comes here? Like, does it affect the mempool or something happens?
We add it to the mempool,
especially the smart contract ones.
We add it to the mempool. That's the answer. We don't do any validation whatsoever.
Interesting. So any validation should happen before the submit TX.
Well, that's
any
the
error,
that's the current state is yes, but that's not how this is supposed to work. That's just how it is right now because we haven't implemented it yet. Our current milestone for Dingo is building the transaction gateway, which will then add validation. And so we're in the middle of adding all of the UTXO validation rules to Ouroboros. We talked about Pluto earlier, which Pluto allows us to do phase 2 evaluations. So in transaction evaluation, there's basically 2 phases. There's phase 1 and phase 2. Phase 1 is basically transaction balancing. Does the left-hand side, do the inputs match the outputs, right? Do they balance? Does the left side equal the right side? That's an oversimplification of what phase 1 is, but that's basically what it is. And that's what we're working on right now. And then Pluto is phase 2, allows you to actually evaluate a smart contract, make sure you didn't exceed, any of the execution units anywhere of the budgets, or right, like any of that kind of stuff, all that cost models, that you saw commented out in Apollo, all of that stuff comes into play there, right? So
I see. Great. So what do you guys think? Should we start, next week to just test Dingo? And of course, actually not testing Dingo, but testing these examples with Go sticky examples here. Or do you guys want to see something else, like testing? I don't know. Do you have? Sure, you can bring. I mean, if you stumble upon something, anything about that, okay. I'm going to leave the links in the chat one by one. But sure, you can go just look into the repository of Blink Labs. But some of these two release, some not some, all of them, but are amazing. But some of them is really just giving you the information that normally, and I haven't seen any other tools provide that, like exactly like NView. So if you are even a stake pool operator and you don't want to do anything about the whole development, you can run this thing, and if you stumble upon a problem or I don't know error or something, you are welcome to bring it here. Sure, the famous Gorobros. And if you are the Go developer and you want to slowly understand what the hell is Cardano, what is blockchain, and what do we mean by blockchain, well, sure, we can start reading the code, the ledger, how these things work to each other. But again, if you have question, like again, if you are a Go developer or Cardano developer, question, feel free to bring it up here. And sure, the dingo, which is starting to create some noises. And I'm seeing people are using. Hey, Eduardo, welcome. How are you? Well, you're a little bit late for like almost an hour. Well, Eduardo, or by his username Zata, is the well, maintainer, founder, writer of the whole Apollo library. And actually, he wrote this for the project that he's founded as well, co-founded as well, which is the Dex Hunter. And well, I didn't know about that, but Eduardo told me that almost 70% of bots running transaction in Cardano, especially DEXs, bots are using Apollo and are using Golang especially because how fast and scalable are. So if you are again looking into AI, bots, trading and stuff, I think you need to look into Golang and Go implementation of that. But let me bring Apollo to the stage. Hey, sorry, Eduardo. Hey, Eduardo, do you want to say something? Like talking about the importance of Golang, or I don't know, something about why should we use, or about Apollo. Eduardo?
Hey,
Yep.
you hear me?
Yeah. I can hear you.
I'm not
How's
really
it going, my friend? Welcome.
Thank you. I'm not really sure what to say, but in general, Golang for me has been very nice because it allows me to prototype much faster than other languages like JavaScript, for example, and it's more optimized.
And have you heard about like Rust implementation? Did you thought about even Rust implementation? Because
Rust is
Rust is
more optimized.
performance.
Yeah, it has better performance than Golang, but it's not as easy to prototype fast compared to Golang.
And was I right about that number you told me about, like 70% of almost transaction?
Double check right now, but I believe, yeah, that should be around the correct number. A second, that I'm deploying something. Exantry is around 60 to 70%, yeah.
60 to 70%. Wow. So already Cardano rely on Golang, of course, Apollo. And I don't know, have you seen this benchmark that we added to the library? And I've done it benchmark with 1 million transaction and 100 of parallel transaction building. And the result was, 10 parallel worker, 2,695 transactions per second.
Yeah, it's pretty fast. I remember when I
Yeah.
was using Cardano, that number would not have been reached at all. Not even near.
Yeah. So it was really great when I first saw this number, but hopefully we can increase it. And then, sure, we talk about other stuff, and I just updating you. Today's meeting is going to be all about Cardano and Golang, all the tools that's already developed and is underdeveloped in or Cardano space. And we talk about some of the ones which are becoming more interested to the community, like the Dingo, because of the whole UTXO-RPC. Chris talked about the whole technology and the design behind it. And hopefully we are going to have UTXO-RPC very soon in Apollo as well. So yeah, the whole transaction building things, I believe, become much faster. Just I have one question, guys. I don't know whom did. I think you guys heard of Gummy Worm by Sunday Swipe. Do you guys think that they are building or writing that with Golang? Do you guys know that? So I actually the question.
It's Rust.
It's Rust. Okay. Okay. The next step of the Golang would be the scalable layer 2 solution written in Golang. So I was wondering if Sunday is doing all the Golang stuff as well. Okay, let me look at the chat.
Mix, I have a question.
Sure.
If you can go back to where it showed the metrics earlier with the transaction speeds,
Sure.
all of this that you presented today is very new to me. So I'm trying to understand um, what are some comparisons that make these results really good? Like what are you comparing these results to?
Well, right now we are comparing the result of the Apollo versions. Like we are just comparing Apollo against Apollo, and there is this a script here. If you want to, there is this a script here, which if you run it, you need to provide 2 version or commit hash of Apollo. Well, you can look into it in details, and it will give you this result. But Eduardo talk from experience. You can maybe talk more about that. This like transaction per second speed, and of course it's not just building transaction, or maybe something can build transaction faster, but handling that, submitting that, is another thing as well. And of course you can see this is a throughout efficiency of the whole things, like using all the resources available for this exact code, how much efficient it was. So hopefully, I don't know, there is a library, or something benchmarking all these transaction building libraries. Maybe there is. If anyone knows, please leave a link or just say where we can find it. But right now, at the moment, we are comparing the transaction building of Apollo to its previous kind of version. But does anyone have any other benchmark they've done in other libraries? Chris, Eduardo, have you done? Like, did you play with other transaction building libraries? I didn't, like, to be honest. I don't know about Eduardo said, not sure, just to speak from experience. Yeah, the time to build with Apollo is much faster than the Python library. It also suppress Lucid. Yeah, definitely I can't argue anything written in JavaScript. Golang or any compile language can surpass them. But sure, we have some great transaction building library. I forgot its name. It is written in Rust. If there was this, so maybe they have some, benchmark. Cardano Wallet, Robot Challenge, partner node.
No, it's just in Palace. Their TX builder is in Palace.
Palace. Have they done any benchmarking? Do they provide any benchmarking? Something?
No, not for just raw transaction, generation. Their focus, like most people's, is on correctness, which is what
Okay.
everyone is still trying to work towards. Is building suites for ensuring correctness and making sure that we're doing the right thing before we make it fast.
Yeah.
So yeah, it's a little different when you're building a pure transaction builder because you're not necessarily doing the validation directly locally, right? So
And also Eduardo saying
Yep.
post a message in chat that actually this is another argument we can say errors is he said that I know some of the projects prefer Apollo compared to Rust libraries. And by the way, there are other libraries, even Haskell, absolutely. I mean, the first building transaction library were all written in Haskell. But, well, for example, we have Atlas. Atlas, well, it's great. But again, this argument always can be really reasonable, legit. That's saying the complexity of the code, choosing Golang, choosing Apollo, or would really just make things much more, maintainable and make sense, and even cheaper for the project to maintain. I mean, for example, like one person just handle or one Golang developer handle all the things. But Rust, no, like just Chris made actually he shared an example that the whole thing here in Dingo was written in 1 week. One week, like the whole stuff that some other project, probably TX pipe, they want to write it in Rust, takes months.
I meant UTXO RPC support was written in a week, not all of Dingo.
The UTX RPC, sorry.
Yeah.
Well, okay. If we can say how much took for dollars, do we have? Okay, so it's been 2 years. I can't say like can we comparatively dumb, like 2 years they are still trying to build this. Well, what was your first commit, guys?
Probably
3 months, 2 months, 3 months ago, 5, 9.
Yeah, look at the
kind of. So yeah,
I mean, it was originally called Node, and we renamed it. So here, renamed it Dingo. It was only 3 months ago. 9 months ago was Node. Yeah, I mean, maybe 9 months ago is probably about right for when we started it.
So yeah, I think that's a good argument. That's a complexity of the code, handling the things is much easier with Golang. So again, great, guys. Thank you for being here. We're going to continue this session. It's going to be kind of live coding as well. Whomever have any Golang, myself, Gimbalabs, we are going to use some of these tools in the backends of the project that we are working. We already implemented some of them, but we have planned to integrate as well. As I said, there is good attention in Gimbalabs community about Dingo. Martin already starting working on it. And we have some project that we need UTXC RPC, as Nelson mentioned in Andami also. We are in need of the UTX RPC. So I think it would be good to start for this session to dive in deeper into the whole Tingo and UTX, UTX RPC and, try to use it. But if you have any question, if you are a newcomer to the whole Cardano, or if you are a newcomer to whole Golang team, feel free to share your question. Hopefully, we will have a dedicated channel in Gimbalabs Discord channel for answering this question. But also, you are welcome to join Blink Labs and, of course, Apollo Discord channel to talk directly to the people who are behind these amazing libraries. And if you want to contribute, you're welcome. But we have a plan in Andamio, and of course Gimbalab and Andamio, that we want to put as much as possible education material about all of these things that we just talk about, like videos, interactive, everything possible in this platform. So you guys can just go through it and learn about it, obtain credential, and hopefully use that credential for participating or even starting new project or new library. You might find something is missing in this whole orchestrate of stuff, whole libraries. Sure, it's a great time to start. And if you have a project, a proposal that needs these libraries or these things, again, you're welcome to talk about it here and share your experience. We have almost 5 minutes. Let me see. Era's question about Apollo. I see.
It's just some questions because this is all quite new to me, so I was trying to get some more background information. So I was asking, what exactly does Apollo do, and what are some of their building libraries?
Does it know about the thing?
Yeah,
I
I gave
don't
you
know
an
if
answer.
Gemini is updated or not, actually. The Apollo TXM libraries. Okay.
Yeah, take a look at it and see if it's gibberish. That would be interesting. That's
Let me open it. Let's see.
But while you're getting that in, and Aris, I think this might help you as well. Harsha was asking in a back channel about like, hey, should we take this course, the Golang? And I really thought about that. Learning how to do it in a different way gives you a better mental model of all the different things that you can do, and then construct a good way of how to think about making business logic and writing contracts. So I think it could be helpful. I'm giving Nick some time to read over this and see if the AI knows what it's talking about here.
Yeah. I think there is this. Yeah, of course. Gemini is kind of create this hallucination like GraphQL. Like we're not. Here, why we are using UTXO RPC? Exactly for this reason, for not using GraphQL. GraphQL was great, to be honest, for the time we used it. James has a great experience. Also, Nelson, great experience. Piotr, great experience with GraphQL Cardano implementing. There were also services for GraphQL, but I can kind of say that's for all time, although I'm talking about like 1.5 years ago. UTXO RPC, I can say, is the future. And that, again, as I said, for exact reason of how flexible, how manageable it is. Like we just saw some of the example here that if you want to get param, this but just let it query here, just get param and that's it. And you're directly getting that param. It's not that and you are querying, I don't know, something, getting all sort of information and just filtering out, picking up something. No, it's not like that. Protocol buff and the whole UTXO RPC. I mean, the whole RPC protocol, is created around that you can retrieve data, like small or big, very very fast, but GraphQL, it came to just solve some of the problem, but that it couldn't that much. So yeah, Apollo has developer tooling with Cardano ecosystem. Sure, it focuses on providing Golang developers with a smoother Cardano development experience. No, that's false. There is no GraphQL implementation in Apollo. Thanks God that there is none, actually. And we have, But yeah, there is Lucid. Well, Cardano CLHL library. I wonder. I actually never heard of Emergo for the whole 2024. I didn't hear anything about Emergo. Like, it was that maybe they are dead or something. This was supported by them. Let's see what they are going to do. But for JavaScript, TypeScript, we have amazing library called Mesh. And it's just not a library, it's becoming an ecosystem for itself. It's going to have TX fee or so-called gas sponsorship. It's going to have wallet as service. It's going to, it's already serving multi-sig services. So if you have a treasury, if you have, I don't know, some sort of wallet that, for example, you posted for Catalyst fund, you can use that service. You can generate the wallet, multi-sig, any number of people out of any number. It is using native script behind the scene. And yeah, it's great. You can manage the funds in that platform.